All right, so previously I made a little bit of a tiny mistake. I didn't realize my handwriting was so bad here that this was supposed to be a 4 and not a 7. So let me just correct that super quick. This is a 4. And so this should also be a 4. Not a huge deal, but if that number were somewhere else, that could have been a big deal. Okay, so we found our RMS current. We know our RMS voltage. And so what we can do is we can really easily determine the power factor and the power delivered by the source, the average power delivered by the source, now that we have these two values. Okay, so let's go to the next slide. I didn't leave the circuit there, so let's just grab this. This should be all we need. I think that is everything we need in order to finish this problem. All right, so we've got our RMS voltage, our RMS current, and we know that our average power is going to be the voltage RMS times the current RMS multiplied by the cosine of the angle phi, which is phi v minus phi I. Okay, so let's write that out again. Which in this case, phi v is 0 and phi I is 13.24 degrees. So actually it's probably better to note that this is the apparent power and this is the power factor. And this problem also asks us to find the power factor, right here. And so let's just find the power factor first. Cosine power factor is equal to the cosine of 0 minus 13.24 degrees. You'll notice that cosine of a negative value is the same as the cosine of the positive value, which is a nice trig identity. This is going to come out to 0.973. That's our power factor. So we found that. And now we're just going to use that in this expression here. So our average power will be VRMS, which is 30 volts RMS. Our IRMS, which is 4.294 amps RMS times 0.973, which is our power factor. And so the average power delivered, if I throw this in my calculator, 4.294 times 30, I get 125.4 watts. All right, so that is our average power delivered by the source. Our power factor is 0.973. And that is example 1110. I think it can get a little bit confusing because the book is using vectors for these IRMS and VRMS, and I can't do that. They're basically just bolding the I and bolding the V here. So if I said VRMS here, they're just bolding it, but I'm going to put a little arrow on it to indicate that voltage and the current are not the same as what I'm using here. I'm using the magnitude of those quantities here. So this is the magnitude, which is just 30. This is the magnitude, which is just 4.294, right, when we make these computations. So let me just go back, and if I made any other, so maybe it makes more sense to write this like this. And probably the same for this right here. I should have probably been doing that the whole time just to remain consistent. But just to let you know that there is basically magnitude and angle associated with this value. But in the formulas themselves, all we care about is the magnitude of the RMS, okay? So I'm going to go ahead and end this video here. In the next video, I'm going to talk about one final topic, maximum average power transfer. It's very practical, very useful, and something you'll probably see a lot throughout your career in EE. So I want to touch on it real quick. But because this module is already pretty long and we still have a lot to cover, I don't want to spend too much time on it. But I will spend one video kind of explaining maximum average power transfer. And if you have any questions about that, just please feel free to let me know. Okay, so I'm going to go ahead and end this video, and we'll see you guys in the next one.